Hello everyone, my name is Srimathi, second year B Farm, studying SNS College of Pharmacy and Health Sciences. I explain the Center for Learning and Teaching. I choose the topic is heat transfer. First of all, artificial intelligence. Artificial intelligence is a theory and development of computer system that can perform tasks that normally require human intelligence. Artificial intelligence of heat transfer. The performance evaluation of counterflow heat exchanger is complex because of the unsteady and non-linear nature of its operating conditions. An efficient neutral network based tools was developed for estimating the outlet temperatures of working fluid from such heat exchanger. For this purpose, a series of repeated experiments were conducted and compared with generalized regression neural network modeling. GRNN architecture proposed in the study consists of four inputs: cold fluid flow rate, cold fluid inlet temperature, hot fluid flow rate, and hot fluid inlet temperature, and two outputs: cold fluid outlet temperature and hot fluid outlet temperature. Such GRNN architecture was trained, tested, and validated with real-time experimental data set. The overall accuracy of the proposed GRNN model is predicting that output of 98% and 96.46%. Heat transfer. Heat transfer is a physical process involving transfer of heat from hot place to cold place. Heat transfer occurs due to temperature difference, example driving force between the points where heat is received and where heat is originating. Heat always tends to flow from point of high temperature to point of low temperature. Objective of heat transfer. Heat transferred through medium, solid or liquid. It may be also transferred through surrounding air. Application of heat transfer. First one, evaporation. It is the process in which liquid transforms into gas through heat by using heat. Second one, distillation. It is the process of separating compounds of mixture based on a different boiling points. We find boiled mixture through heat. Third one, drying. Removal of water or another solvent by evaporation from solid and semi-solid. The fourth one, sterilization. Any process that removes, kills, or deactivated all from life. Example, microorganisms. Mechanisms of heat transfer. It involves three processes: conduction, convection, radiation. First process is conduction. In this heat transfer in a solid in series, it may be through fluid, but fluid should be in stationary. In this, particles are directly connected with each other and heat transfer through one by one. It depends upon the temperature gradient because heat transfer from high temperature to low temperatures. Now, when we provide heat at one end of substance, then particles of that end vibrate vigorously and then they collide neighboring and transfer their energy. And this process should be continuous until the last end particle should absorb heat. Next process is convection. It is the transfer of heat through the movement of liquid, in which initial position particle absorb heat turn displaced with final position particle. It is also mode of heat transfer which occurs mostly in liquid and gas. In this method, heat transfer takes place with the actual motion of the top to come down and thus heat up. Radiation. It is another form of heat transfer. It does not require any medium and can be used for transfer of heat in a vacuum as well. This method used electromagnetic waves which transfer heat from one place to other. Example of heat transfer radiation: a burning candles and hot bricks emits radiation in a form of heat and light. Fourier's law. This law states that rate of heat flow through a uniform material is proportional to the area and the temperature different, while it inversely proportional to the length of path of flow. Q equal to minus K into delta T. Q is a local heat flux density. K is the material's conductivity. Delta T is a temperature gradient. The different form of Fourier's law, thermal conductivity shows that the local heat flux density is equal to the product of thermal conductivity and the negative local temperature is gradient. The heat flux density is amount of energy that flows through a unit area per unit time. Fourier's law is a Qx equal to minus k into A dt by dx. Integrating form. Fourier's law describing the rate of heat conduction in a solid. Boundary conditions. X equal to x1, t1 equal to t, x equal to x2, t2 equal to t. Separating the variables. Integrating from x1 to x. Fourier's law derivation. Rate of heat conduction proportional to area and temperature different. Q conduction equal to Ka T1 minus T2 by delta X equal to minus K delta T by delta X. The three-dimensional form of Fourier's law gives us Q equal to minus delta T. Thank you for these opportunities.